Hello. Oh, just a sec. Ah, hello. Um, my name is Hagen Patzke, and this is a talk about a Jupiter Ace on an FPGA. So I will not go into depth what an FPGA is, a field programmable gate array. But let's have a look what a Jupiter Ace is. Just a sec. We want slides. So how does it look? This is how it looks. That's a photo from the internet. I was very lucky to be able actually to use one of these Jupiter Aces on a Vintage Computer Festival Europe fourth benchmark session a couple of years ago. And when I was looking for something to implement on a field programmable gate array chip for fun and practice, that was a logical thing because they are quite rare and they are special. Jupiter Ace is one of the only ones, if not the only, home computers which don't use BASIC, but they actually have a different programming language. You program the Jupiter Ace in Forth, and that's already quite special. What you can see is it looks a little bit like a cross between a ZX81 and a ZX Spectrum, and that's not so far from the truth because the people who designed it originally worked at Sinclair, and they were designing the ZX Spectrum, but they wanted to have a fourth machine, not with color. Black and white was fine. The ZX81 had black on white, so the background was white and the text was black. The Jupiter Ace had the more traditional white on black. Personally, I think that's easier on the eyes, but that's a matter of getting used to it and your environment. The interesting thing with the Ace was also that you basically type the commands individually in. So it's not like the ZX81 or the ZX Spectrum that you type a key and then you have a keyword or something. It's also difficult with Forth because you can define your own names and your own words in Forth. So that wouldn't have worked anyway. That's how it looks inside. Not super special. Printed circuit board, this green thing. Proper keyboard contacts, which is nice. A speaker, so it could beep or play music, simple music. 9-volt input power, tape ports for microphone and ear, microphone input for the tape recorder and the ear output from the tape recorder. Video chips, TV output, modulator, 6.5 MHz clock. That's also used to make the video signal, and and it's divided by 2 and is used to drive the clock for the CPU and the rest. Memory expansion port compatible to the ZX81, so you can extend the built-in RAM. Let's have a look at the specs. So it was released 1982. The designers or the engineers who made it were Richard Altwasser and Steve Vickers. Richard Altwasser, the hardware guy, and Steve Vickers wrote the software and the manual. They founded a company together, the Jupiter Camtab Limited. It didn't live very long, and from what I know, about 5,000 Jupiters were sold, or produced at least. 2 different versions, one injection molded, and the first ones were obviously done with a thermoplastic process. So I guess the first ones felt a bit cheaper than the later injection molded ones. It's not so much different from the ZX81 if you look at the specs. Let's compare them. The main difference is that the Jupiter Ace has 2 additional kilobytes RAM, but that's not user RAM. 1 kilobyte is for the video buffer and 1 kilobyte is for the character set. that thing has a redefinable character set. The character set is copied from ROM into RAM when it boots, and then you can modify it. The only drawback is you cannot read the character set. You can write to it and redefine it, but you can't read it. There are some programs to do some pseudo high-res graphics, as high resolution as you get with 256 times 192 pixels, 32 characters times 24 lines, and each character is 8 by 8. So that's what you have. It's very low res for today, but well, if you can plot a curve or something, that is something, and there are software packages to allow to do this function plotting and everything. So you can see the ZX81 had most of its logic combined in one big chip, the Universal Logic Array. The Jupiter Ace, you could say, is a little bit like a souped up special version of a ZX80 maybe, because the ZX80 had the logic also in individual TTL ICs. There's another specialty. The Jupiter Ace can be extended to up to 48 plus 1 kilobytes. The Sinclair cannot, the ZX81, because the higher 32 kilobytes are used to generate the clock for the video signal. So the CPU basically jumps at an address higher than 32,768, and this means that the highest address line is high, and if that's set, then the CPU doesn't get what is somewhere in RAM or whatever, but it gets knobs until there's a halt, and the Sinclair computer logic fetches the data from the video RAM and the video data from the common RAM and displays characters with it. It's quite ingenious. But the Jupiter Ace actually has its own video generation. It also has something like a slow and fast mode, but it means something different. The Jupiter Ace is a fourth machine, so it's stack based, and there's a lot of checks, and if you have a trusted program, you can switch off some of these checks. We want to bring this onto an FPGA chip, emulated in emulated hardware. Luckily, somebody did the heavy lifting already. There's a project ZXGate, which is also implements other home computers. I think ZX81 is one of them, but also the Jupiter Ace. And yeah, it uses one of the cores from OpenCores.org, the Z80 core. Z80 because of Zilog. The Zilog company had the rights on that. It has basically almost everything. What you can also see is it makes sense. The keyboard interface with lots of lines and really keys in a matrix is usually replaced with a PS2 keyboard interface. So you can actually then plug a PS2 keyboard into the emulator on an FPGA and use that one. This is what I used. Let's look at the specs. So the smaller PCB is a Papillion 500K. It's a Xilinx XC3S500E, Spartan 3E. That's where the 500K comes. 500K gates, more or less, logic elements or whatever. It already has a USB programmer. It's open source. And it supports extensions. And one of the big extensions is the Arcade MegaWing, which has VGA connector with 4-bit RGB video, so 4096 different colors. We only need one, black and white. It has 2 PS2 connectors, 2 joystick connectors, 5 buttons for reset up, down, left, right. Please understand the reset button doesn't have any special meaning or something. It's designed to be used as a reset button, but it's basically something which is just connected to the FPGA port, and I used it in the reset function, but you could do this differently. And then 4 LEDs for status and stuff, and an earphone jack. As said, we have most of the stuff is done in the ZXGate. What else do we need? We need to get the proper CPU core. We need to implement clock generation, 6.5 MHz, and we need to generate RAM and define RAM for user programs. And because we have an arcade megawing, I would like to have VGA output, sound input and output, and I learned quite quickly we need something called button debounce. At the beginning I didn't debounce the reset button, and that means that sometimes when my hand came close to the device, because shielding is not brilliant, it could pick up some static charge and then just trigger a reset. Not so good, so you want to debounce that button. This is a schematic overview. So you can see on the left hand side the clock generation. There's also 16 MHz for the VGA output, because the VGA needs a little bit different frequency. This works with dual ported RAM. So the ACE VGA internally has also video and character RAM, like the ACE block in the middle, but it's dual ported and it's read out for the VGA with a different frequency. That means the Papillion 1 Jupiter runs on its designed 50 Hz, but the VGA output uses 60 Hz. Then we have 1K RAM and 16K RAM. 1K RAM is extra because you can see it 4 times in the memory map. It's not fully decoded, and also it's a bit the question what has precedence over RAM. That's for video then, but so this is the reason why the RAM block is for 1 kilobyte is extra. It's basically a 4K block, but it's 4 times 1 kilobyte, and the 16K block is like an extension, a memory extension. The Papillion 1 500K has a chip, a Spartan chip, which is big enough to have a lot of special block RAM units on the chip. So actually you have 16K usable RAM. That's or 17. That's really nice. You see an audio multiplexer because we have only one stereo jack. So microphone and ear from the tape needs to go via that, and also the audio, the beep output. That's how it looks if you open this in the Xilinx ISE. Not exactly like this. You have a bit more around it. You see the top level modules. Everything else is basically defined in Verilog, so that's just text. But this gives a little bit of an idea what components are defined and how they are connected to each other. Buses and signals with the same name are connected. So the layout is not 100% reflecting or immediately showing all the connections. Looking a bit deeper into the debounce and into the sound selector, I want to comment how I did the debounce. So on the top left you see basically a latch, a triggered latch with a clock input, and the output of this latch is compared with the input, and if they are the same, then the counter on the right hand side is reset or held in reset. If they are different, the counter can run. It gets in, I think I use 16 MHz for that, to let the counter count up. And when one of the address lines is high, then the latch takes over the new input. And then input and output are the same, and the counter is reset and waits for the next change. This makes it actually possible also to define how long the debounce takes. I think I took something quite long because it doesn't cost anything more or less if you have a logic element and it has a counter. It doesn't really matter if you count till 16 or if you count till 1024 or even higher. So up to within limits, it doesn't cost more resources on the chip. And so I used quite a long time. Also, the only 2 buttons I needed were the reset button and the audio multiplexer button. So if that debounce is 100 milliseconds or so, this is fine. On the bottom you see the sound multiplexer. And this is one of the instances or the cases where you actually need input and output. So these are tri-state buffers at the bottom right. And they can be, so if it's switched to microphone, it's using the signal and forwards it to the ACE core, and if it's for output, the proper selected beep or tape output is then set as an output. Tape problems. Yeah. So I started trying to load data from a laptop or from a desktop. Audacity is my friend, and also a couple of helper programs. And very often any attempt to load anything aborted with error 10. And error 10 is the tape load error. B-load is binary load. So load for forth programs and B-load with an address to load binary data into memory. It would be nice to load something from a mass storage device, from an SD card. So if I had a different FPGA platform or more pins left over, I could connect an SD card module and use that one, but then you also need something which actually drives it. So you need like a processor and some memory or something. So that's a bit more effort, but it would be nice to be able to load programs from an SD card and save them there. Then we have still defined black and white video blanking sync video output. Usually the cable for that is yellow, or the plug for that. We should either make it available somewhere or remove the unused resources. It's not super important, but the tape problems are really a problem. And the tape problems are not new. The original platform already had tape problems from the design. I think that's the reason why they actually eventually went for the ZX Spectrum format, because they knew that that would work. But they were still fighting with it. And the Jupyter Ace users were also fighting with it. There's a Jupyter Ace users club in Brighton where people collected 2 pages of hints and tricks, and then Boldfield Computing later published this for everybody to get. One of the things I noticed when I try to load something from tape, or in this case from a laptop or something, the monitoring LED which I had configured luckily started to light up, and then it stayed on. And that was due to the fact that the earphone jack is actually designed as sound output from a delta sigma converter. So all you need for that is basically you make pulsed output, and the more of the pulses which are on high level, more 1, the higher the voltage gets at the output, and the more it's to ground, the lower it gets. And if you do this in a good way with a low pass, you can actually get decent quality output. It's not brilliant, but it's decent quality. The Raspberry One or the Raspberries have this with their audio jack as well. So it's not super high quality, but you can get a turnout. For an arcade thing, that is fine. If you want to use that as an input, it's a problem because there's a low pass in there. That means there's a capacitor which charges, and I found out the hard way that it's charged, but the FPGA doesn't draw a lot of current from it, so it's not discharged. So a little 3 component schematic basically rectifies that. It's not a PCB, it's basically on a breadboard, a small circuit. And with that, loading works a little bit better. Well, not really a lot, but a bit better. And in 2021 I've stumbled across the TZXDuino, an Arduino project to playback Spectrum files from an SD card. Sounds good. also adaptations for other platforms. Then I found an Etsy page for that. So somebody sells devices, £20. That's a deal. Let's get one. Nice. I think it has a metal casing even. You see an LCD panel on the top for the file name and the progress indicator. And then you see the navigation buttons, stop, play, pause, up, down in the menu. And I think red means go back to the top level menu. A little bit like a reset. It's not a reset, but something like this. Really nice thing. So it's a cassette player replacement. And this looked exactly like what I wanted. Uses an SD card to playback files. It doesn't have it doesn't support the save function of the platform, but it supports a lot of other stuff. And then I found there's a TZXDuino kit by You Make Robots for £16, even cheaper. Cool. So let's order one of these. No. Well, I tried, but Duncan Edwards doesn't ship to the Netherlands where I live. And You Make Robots does ship, or do ship, but shipping and potentially also the cost on the other side here, receiving it, it's possible that I also have to pay something, a handling charge or something, is basically the same as a kit. So that's not really economically viable. And the You Make Robots thing also doesn't have a housing. That was the thing which attracted me to the version Duncan Edwards has made. It's just a really nice device. What can we do? Well, we can use an Arduino clone, a generic Arduino, Genuino, and an OLED and an SD card reader and a few buttons. And I had a display module from Velleman with a LC display and with buttons. I don't use the display, but the buttons are useful. And I had on the bottom left, you see actually a little piezo speaker, so you can actually see that it works. And I had an ODROID-GO. I found that one by Reichelt. That's actually made by a Korean company, Hardkernel, and they originally started, I know them from my time at Lauterbach, when we had test platforms for ARM-based computers or Android platforms, and their ODROID brand, this comes from ODROID, from Android, was a platform for developers. They have made different devices. This one is shaped like a Game Boy. That was basically to an anniversary of the ODROID brand. They use an ESP32, which is quite nice because you can also use Wi-Fi or Bluetooth if you have some software running on it. It has a built-in battery, rechargeable lithium-ion battery with plugs, so you can replace it easily if necessary. It has an SD card slot, and very important, on the top it has 10 pins which you can use. So there's plugs where you can something like 6 I/O ports are accessible from the outside. The other ones, the other 4, one is key, and I think there's ground and 1 or 2 voltages. That's the reason why you can't use all of them as input-output. You also need ground, whatever you do. And this is quite a nice thing. Also has enough buttons to make actually using a TZXDuino very simple and easy to use. And this also has a loader which allows to load different designs from SD card, different software, and write that to Flash, and then you can use something else. That thing can actually play Doom if you want to. Why did I start a generic Arduino version? Because I needed to change the TZXDuino code to run on the ODROID-GO platform. It is a different processor than the Arduino. There is Arduino stuff for the ODROID-GO, but some things you need to do slightly different, specifically if you go into the low-level things like interrupt handling and everything. I did a lot of refactoring and cleanup. One of the bigger things I did is I made the interrupt routine much simpler and added a detection of overrun. The TZXDuino is quite interesting. It reads the data from a file and interprets it, and then writes it basically into a buffer. The buffer has two parts, so it fills one half of the buffer, and an interrupt routine goes and reads the buffer content, and the content is just which level and how long something needs to be at the output. And with this one you can get very, very well defined waveforms for output, very crisp and very correct within reason and within time. The only problem is if the interrupt routine must never run quicker than the generation routine for the data. And I had the problem that this happened sometimes. And I found out where it came from, and it came from a battery state check, which was running several analog digital sample cycles in order to average the measured battery voltage to make sure you don't undercharge the battery. It doesn't go too low. The voltage doesn't get too low, because it could damage a lithium-ion battery. And once I found out what the problem was and didn't do the battery check at every interpretation loop, but only when you're in the menu system, the problems were gone. Then I found out in this works that the Jupyter Ace tab file format has a specialty. There is a byte missing. The emulators don't mind, they don't use it. But a real Jupyter, if you transform this tab file into WAV files and into a waveform with the TZXDuino, and then you try to load it with a Jupyter, the missing byte harms you, of course. And it's something which is missing in the tab files. So you can detect it, that it's missing, by looking at the length of the header block data. Yeah, so I added a check for this as well. But this block type marker, this missing block type marker, is the root cause for most tape loading problems. So I identified the problem, and then, okay, and then almost everything works. One of the findings, which was not absolutely clear to me, is that the Jupyter Ace tape format, it has different, if you look at the TZX specification, it has different clock cycles and everything, counts, but for the different types of waveforms you need to load, but it's almost 100% identical to the ZX Spectrum when you adjust it for the difference in CPU clock. That's quite interesting. So we have now a lot of resolved issues. We have no tape problems anymore. Load and beload work reliably. On the right hand side you see me trying to load something. Program actually does exist and I have the file for it, but it finds a lot of the other demo programs reliably now. It's from mass storage, from SD card. Well, not directly part of the emulator, but ODROID-GO is also very handy. I have published the changes I made for ODROID-GO and Jupyter Ace. Still, there was no save. At the time when I made that slide, because later then I found somebody had made a tape interface for the ZX81 called the ZXVSP, and even a version with video. That's amazing. But the simple version only has two connections, basically, for microphone and tape. The interesting thing is this VSP is an ESP32 based system. It implements also a web server, so you can basically upload something from your computer to the web server, and then you can download this to your ZX81. And the ZX81 can save something, and then you find that by the web interface and can download it on your PC. This is possible because the ZX81 can have file names up to 127 bytes long, And this mechanism is used to communicate with the VSPE and give it commands. So basically at the beginning you load a random program, and the ZX81 will then generate a recognizable waveform which the VSPE detects. So the video output then has a specific form, and it can detect that ZX81 is trying to load something. So if it doesn't get any special request, it's sending a menu program, and then this menu program is using special commands basically and its own protocol to load data and everything. It's an amazing piece of software. I managed to add some function which allows me to get data from the Jupyter Ace and make it available for download over a web server. So I can also save. It's a different device and it's different, but it works. So that gives hope that eventually I can also make a device which does both. This is how the VSPE looks like. On the left hand side you see the ESP32 with a white button and just a bit of cable, so basically no components or not much. And then you have a little breadboard with the audio interface I needed. The dark brown little board is just a DB9 connector. It was harvested from an uninterruptible power supply, and it had already the right pins which I needed to interface to a breadboard, so I used this one. Just had it lying around. And this is how the new tape adapter looks like. The resistors you see are part of the joystick connector to protect the FPGA from spurious voltages or something. I mean, any externally connected source can damage a chip, of course. You don't want to do this. And you see it's basically two capacitors, a piezo beeper, and a resistor. And that's it. More is not necessary, and it's very reliable. This works with the ODROID-GO, and it works with the VSPE. This is the changed schematic, to say, the schematic overview. You can see the multiplex is not necessary anymore. So the only key I need at the moment is basically a reset, and that's it. That was it basically. Here now the collection of links with information about the Jupyter Ace itself. Honorable mention, Grant Ziel, build your own Jupyter Ace page. He really retraced the circuit board and everything, so and provides everything you need, information you need to build your own Jupyter if you get all the components. Some historical information. Components, ZXGate, big help. The open course project with the CPU. And I found a really good blog post about a vendor independent way of defining RAM in a way that Xilinx and Altera both, so the Altera is now part of Intel, but both FPGA types, the compilers for these FPGA types will recognize that this is RAM, and they will use the most efficient internal mega function to use their block RAM, which is on an FPGA. Most gate arrays have some extra components for special cases, for example digital signal processor units or special multipliers or something like this to speed up frequently used functions, and RAM is one of them, and it's very important that you use the block RAM. And this is even dual ported RAM, which is really good if you want to have a different frequency output like VGA for a computer which was designed for 50 Hertz 50 Hertz operation for video output. I mean, the power frequency was 50 Hertz. About the implementation, the Papilio 500K, a little FPGA page I made with an overview of some of my FPGA projects, the Papilio 500 implementation on GitLab, My helper programs for Jupyter Ace tape conversions, so wave file to tape file, tape to wave, and TZXDuino, and the TZXDuino stuff I made. Have fun with it. Tell me about my mistakes and bugs if you find anything. If you're interested to know really how the refactoring and everything worked for the TZXDuino, then if enough people are interested, I will happily make another talk about this one. It's quite interesting to look into tape formats and make them usable. And this is basically it. This is the talk. I hope you enjoyed it. I hope you found something of interest, and it would be nice to see each other maybe on a vintage computer festival, or maybe a retro fair, or if you are in the vicinity, if you come to the Netherlands, to Utrecht, we have here Awesome Space. That is a place from the Awesome Retro Club. Look for Awesome Space in Utrecht and you will find us. And we have normally open days on Wednesdays and Fridays. So if you like old hardware and games, drop by and in the evening and have a good time. That's it from me. Looking forward to your feedback.